So we have seen what is meant by molecular polarizability, what is polarization, what is electric polarization, and what are polar molecules and what are non-polar molecules. Can you give us some examples for polar molecules? Yes, H2O, N2O, NH3, HCl. What are the examples for non-polar molecules? N2O, H2O, and O2. Then we will go for some applications of this capacitor. So what is the capacitor? A capacitor is a device used to store the charges. So on what factors does the capacitance of a conductor depends upon? The capacitance of a conductor depends upon the geometry of the conductor and also on the nature of the medium. It will not depend upon the material with which the capacitors are made. Now we will go for some applications of the capacitor where these capacitors are used. First one, the capacitors are used in automobile machines to eliminate the sparking. So first one, they are used in automobile engine in the ignition system to eliminate the sparking. Second one, they are also used to reduce the voltage fluctuations in power supplies and also to increase the efficiency of the power transmission. So in the power transmission, to increase the efficiency, we are going to use the capacitors. The last one, they are also used to generate electromagnetic oscillations. They are also used to generate electromagnetic oscillation and also used in tuning radio circuits. So these are the few applications of this capacitor. Now if I have number of capacitors, they are connected like this. Here I have that n number of capacitors are connected end to end. How they are connected? They are connected end to end so that the charges produced in each capacitor is same. So the charges produced in all this capacitor should be the same. If I connect the capacitors like this, then I can say the capacitors are connected in series. Let C1 and C2 and C3 be the three capacitors connected end to end such that the charges produced are same and the potential developed is different. Let V1, V2 and V3 be the potential developed in here. So how I can say when the how capacitors are connected in series? In the capacitors, when n number of capacitors are connected end to end such that the charges developed in each capacitor is same, then I can say the capacitors are connected in series. Parallel. And n number of capacitors, when the number of capacitors are connected to the two terminals, here I have three capacitors, they are connected to the two terminals such that its potential difference developed across each capacitor will be the same. The potential developed across each capacitor to be the same, then I can say these capacitors are connected in parallel. So now we will see when the capacitors are connected in series, what happens to the effective capacitance, and when the capacitors are connected in parallel, what happens to the effective capacitance. When the capacitors are connected in series, the charge remains to be the same, the charge developed in each capacitor remains to be the same, and the potential will be the difference. Here I want to find out the total potential developed. It is given by the sum of all the three potentials, V1 plus V2 plus V3. We know that C equal to Q by V. From this formula, what is V? V equal to Q by C. Here, if it is V1, it is Q by C1. Why I am not writing Q1? Because the charges developed in all the three capacitors are to be the same, plus Q by C2 plus Q by C3. V1 equal to Q by C1, V2 equal to Q by C2, V3 equal to Q by C3. Now this is the total potential. Let Q be the total charge developed here and let C be the effective capacitance connected in series. What is Q here? The total charge developed, it will be the same. And Cs is the effective capacitance when the capacitors are connected in series. In all this 3Q is common. See, take it out. What is the remaining? 1 by C1 plus 1 by C2 plus 1 by C3 Q by Cf. This Q gets cancelled. What is the remaining? 1 by Cf equal to 1 by C1 plus 1 by C2 plus 1 by C3. So, this will be your effective capacitance when the capacitors are connected in series. So, how I can define? So, the reciprocal of the effective capacitance when they are connected in series will be equal to the reciprocal of the sum of the individual capacitance. In this way, I can find out the effective capacitance when they are connected in series. Now, all these capacitors, let C1 and C2 and C3 be the 3 capacitors which are connected to the 2 terminals such that the potential difference across each capacitor remains to be the same. Then this type of connection I can say they are connected in parallel. Now, here the charge developed in each capacitor will be different. So, the charges developed here when they are connected in parallel will be different and the potential developed will be the same. So, here you want to find out the total charge developed in these capacitors when they are connected in parallel. It is given by the sum of the charges of the 3 capacitors. Let Q1 and Q2 and Q3 be the charges developed in these 3 capacitors. By the formula we know that C equal to Q by V. What is Q then? CV. Here for Q1 I can write C1V plus C2V plus C3V. Here this is the total charge. This is given by, let Cp be the effective capacitance of all these 3 capacitors connected in parallel into the potential developed. Here take the V out, common C1 plus C2 plus C3. Here sweep, this V gets cancelled. So, what is that? Effective capacitance. It is equal to the sum of the capacitance of the individual capacitors. So, the effective capacitance when the capacitors are connected in parallel is equal to the sum of the capacitance of the individual capacitors. So, in this way I can find out the effective capacitance when the capacitors are connected in series and in parallel. So, already we have seen in a capacitor how the charges are stored and what are the different methods of storing the charges, the properties and all we have seen. A capacitor is a device used for storing the charges, isn't it? We are not going to move any charge from one plate to another plate. Just we are going to do some work to store the charges in a capacitor. That work done in storing the charges in a capacitor will be at electrostatic potential energy. That work done will be at potential energy. Now we will be seeing how will be the energy stored in a capacitor. Energy stored in a capacitor. Let this be plus Q, let this be minus Q. Yeah. Let Q be the charge given to a capacitor. Because of this charge given to a capacitor, let V be the potential developed in the capacitor. Now, already we know if the charges given, if I increase the number of charges given to a conductor or a capacitor, then its potential also increases. Isn't it? Both are directly proportional to each other. Q is directly proportional to V. Now, I am going to give an additional charge of dQ to this capacitor. So, what we are going to do? We are going to give an additional charge of dQ to a capacitor. Thus, there will be a increase in potential. Let V be the total potential developed because of the additional charge dQ given to the conductor, capacitor. Now, we want to find out what is the work done in storing the charges in a capacitor. Because of that, a potential V is developed. Work done is equal to, we know C is equal to Q by V. From this V equal to Q by C. From this formula C equal to Q by V, V equal to Q by C. First we will find out what is the work done in storing this charge. What is the potential formula? Work done in moving a unit positive charge. What is the formula for potential? Work done in moving a unit positive charge. So, work done equal to V into Q, isn't it? So, first we will find out what is the small amount of work done in giving an additional charge of dQ. So, dW equal to V into dQ. Now, you write this here, dW equal to V into dQ. What is V here? The potential developed because of the charge given to a conductor. It is given by the formula V equal to Q by C dQ. So, dW will be equal to this one. Now, I want to find out what is the total work done in storing the charges Q because of that. Let V be the potential developed. I can find out by integrating the between the limit Q to 0 to Q. Yeah, so let Q be the amount of charge developed because of let V be the potential. So, if I integrate this small amount of work done between the limit 0 to Q, I get the total work done. This work done in storing the charges will be its electrostatic potential energy. So, just substitute what is dW. It is given by Q by C dQ. Now, the C is constant. This is nothing but the capacitance of a capacitor. Take it out. 1 by C, integrate this Q dQ. What happens if I integrate this Q dQ? It will become Q square by 2 between the limit 0 to 2. So, upper limit minus lower limit. What you will be getting? Q square. You can take the 2 also outside. Q square minus 0 you will be getting. So, here this work done in storing the charge Q is given by Q square 1 by 2 Q square by 3. So, this will be the work done in storing the charge Q. Thus, now we know that C equals to Q by V. From this, can I write what is Q? C, V. So, in the place of Q, I can also substitute the CV. Here it is Q square. So, it will become C square, V square. This C square, V square. So, in the place of Q square, you substitute this. What happens to this work done? It will be equal to 1 by 2 C square, V square by C square. So, 1C and 1C gets cancelled. Then what is the remaining? 1 by 2 C V square. This work done in storing the charge Q will be its electrostatic potential energy. So, the work done or the energy stored in a capacitor is given by half CV square. So, what happens if the charges are distributed to different conductors or two different conductors of different shapes? That we will see. Now, what happens if the charges are, how the charges are distributed in a conductor? Here I have two spheres. Let A be the sphere of radius R1 and B be a sphere of radius R2. So, here I have two spheres of different radius and these two spheres are connected by a conducting wire. Clear? Now, how will be the charges distributed on these two spheres? We are going to see they are connected by a conducting sphere. Let the system in the sphere A, let Q be the charges distributed Q1 and let Q2 be the charges distributed in the sphere B. Now, we know that already for a point charge, how will be the potential developed? Can you say the formula? How will be the potential developed or potential developed due to a point charge? This is given by V equal to Q by 4 pi epsilon naught R. So, this will be the potential developed due to a point charge. Here I have two spheres of different radii. Let VA be the potential developed due to the sphere and let VB be the potential developed due to the sphere B. Now, since these two spheres are connected by a conducting wire, the potential developed at these two spheres will be the same. So I can equate this VA equal to VB. Now you substitute what is VA and VB by this formula. I can write VA as Q1 by 4 pi epsilon naught R1 is equal to VB equal to Q by 4 pi epsilon naught R2. Let sigma be the surface charge density of these two spheres. What is sigma? Charge per unit area. From this, what is Q? Q equal to sigma A. I can also find out what is the charge stored in these two spheres by this formula. For Q1, how I can write Q1 by this formula? Sigma, let sigma 1 be the surface charge density and let sigma 2 be the surface charge density of these two spheres. So Q1 equal to sigma 1 into the area of the sphere. It is given by, what is the area of the sphere formula? 4 pi R square. It is R1 square for this sphere A, and for this sphere B, it is given by sigma 2 4 pi R2 square. Now you substitute these two, that is the charges Q1 and Q2 here. What happens if I substitute these two? It is sigma 1 4 pi R1 square by 4 pi epsilon naught R1 is equal to Q2 is this one, that is sigma 2 4 pi R2 square by 4 pi epsilon naught R square. Simplify this. 4 pi, and here 1 epsilon naught, here 1 epsilon naught. 1 R1 gets cancelled. Here also 4 pi, and 1 R2. 1 R2 and 1 R2 gets cancelled. So what is the remaining here? Here I have only sigma 1 R1, sigma 1 R1, here sigma 2 R2, sigma 2 R2. That is the product of the surface charge density into the radius will be the same on both the spheres when it is connected by the connecting wire. When these two spheres are connected by conducting one wire only, I can say the potential developed at these two will be the same. I can write this also, sigma R equal to constant. What that means? Sigma R is equal to constant. That means the surface charge density will be inversely proportional to the radius of the sphere. That is, if the radius is less, if the radius of the sphere of any conductor, if the radius is less, the surface charge density will be more. So, here I have a conductor to be of this shape. For example, I have a conductor of this shape. So, this is the shape of a conductor, and the one end is sharp, the other end is like this. So, this is the shape of a conductor. So, this sharp end, one end it is very sharp. What happens to the radius at this point? At the sharp end, the radius is minimum. So, if the radius is minimum, what happens to the surface charge density? It will be more. So, the charges will be accumulated to a maximum value, or more number of charges will be accumulated at this sharp end. Why? Because here the radius is minimum, and I can also say the curvature is maximum and the charges stored are more. So, by this we came to the conclusion, it is also experimentally proved that the sharp ends of a conductor, at the sharp ends of a conductor there is some leakage of charges. So, here this is the sharp end of a conductor, or you take a conductor like this shape, like a comb shape, or like it looks like a spikes. So, these sharp ends, this conductor, at the sharp ends the radius is very less. If the radius is very less, the surface charge density is more. That is, more number of charges are stored at this end where the radius is minimum and the curvature is maximum. So, what happens? It is also found, and it is also proved experimentally, more number of charges not leaking. That is the loss of charge or leakage of charges at the sharp ends of a conductor. So, why? Because, can I explain why the charges are leaking at the sharp ends of a conductor? See here more number of charge density is more. More number of charges are accumulated here. So, what happens to this? In its vicinity, the air molecules surrounding it gets ionized, and So for example, these are positively charged. Positive charges are shown here. The air in its vicinity gets ionized and the positive and negative charges will be attracted towards it and the positive charges will be repelled away due to the force of repulsion. So the negative charges, what they will do, they will neutralize the charges at the sharp end. So this is the reason, due to the ionization of air only, there is a leakage of charges at the sharp ends of a conductor. This principle we are going to use in the lightning arrestor or the lightning conductor and in some electrostatic machines to store the charges. So we are going to use this in lightning conductor. So we already know what is the use of this lightning conductor. So this leakage of charges from the sharp ends of a conductor, we call it as the action of points or corona discharge. So what this is called, that is the leakage of charges at the sharp ends of a conductor, we call it as corona discharge or action of points. So this principle we are going to use it in the lightning conductor and also in some electrostatic machines to store the charges. First we will see how is the lightning conductor work and how it is constructed. So what is the major use of this lightning conductor? What for we are using this lightning conductor? To safeguard any building from the damage of the lightning. If there is a heavy rain, due to that heavy rain, if there is a lightning, what happens if you are not having this lightning conductor? Definitely your building will be damaged by this lightning. So we are having all the tall buildings, they are having a lightning arrestor. So here this lightning arrestor on the top, from the top, for example this is your building, at the a very thick copper rod. A thick copper rod will be passing through the building. At the bottom of the copper rod will be having a metal plate which is buried deep into the ground. So here this is a thick copper rod. The bottom of the thick copper rod I have a metal plate which is buried into the ground. At the top of this copper rod I have a cone shaped metal which is fixed at the top of the building. So this is your construction of your lightning conductor. Now what happens during lightning? The negatively charged cloud will be passing on the top of the building. When a negatively charged cloud passes through this, due to the induction process, what happens? This fully negatively charged. So by the process of induction, what is meant by induction? We are going to produce charges without any contact with another object. So this negatively charged cloud, when it passes through the top of your building, at the sharp ends of this conductor, positively charged, it induces a positive charge to this conductor. Now this gains a positive charge. Now what happens here? We know that the charges which are accumulated at the sharp ends, more number of charges will be accumulated because we know that sigma is inversely proportional to r. If the radius is less, more number of charges will be accumulated. Here we have these positive charges, what they will do? Will they be there or will there be leakage of charges? We know that it will be leaking or there will be loss of charge due to the action of point. Why there is a leakage of charges? Because air in surrounding it gets ionized into positive and negative charges. The negative charges will be attracted towards the sharp end and this get neutralized and the positive charge will be repelled away. This positive charges, what it will do? It will lower the potential of the negative charged cloud. So what happens here? First, when a negatively charged cloud flows, when a negative charged cloud is passing through the top of your building, since you are having the lightning arrestor, here by the process of induction, a positively charged thing, it gains a positive charge or the sharp end. Then due to the action of points, when the air gets ionized, here the negative charges will be attracted towards the sharp ends of the conductor and the positive charges will be repelled away due to the force of repulsion. These positive charges will lower the potential of the electron cloud and the negative charges which are attracted towards this lightning conductor will passes through the copper rod and it reaches the earth and it will be earth. By this you can safeguard your building from the damage of the lightning. So first thing, what is happening? When a negatively charged cloud passes through the top of the building, due to the process of induction, this spike, that is the comb shaped conductor, it will gain the positive charge. We know that more number of charges will be accumulated at the sharp end. Then by the action of point, the charges which are stored at the sharp ends get discharged due to the ionization of the air in its surroundings. When the air gets ionized, the negative charge will be attracted towards the sharp end and the positive charges will be repelled away due to the force of repulsion. These positive charges, what it will do? It will reduces the potential of the cloud. Why? Because these two are unlike charges. Already we have seen when there are two unlike charges are brought closer to each other, what happens to its potential? It decreases. So by this, that is by the process of action of points or due to the ionization of air, this potential of the cloud decreases and the negative charges which are attracted towards the copper rod passes through the ground and it is lost. By this, the building is safeguarded from the lightning. It is protected from the damage by the lightning arrestor. This is your working and construction of your lightning conductor. You may get this in 3 marks. Then we will go for this Van de Graaff generator, which is the electrostatic machine. What is the major use of this electrostatic machine? It is used to store the charges. So what is the main use of a Van de Graaff generator? It is used to store the charges. In a Van de Graaff generator, we are going to use both the principles, that is electrostatic induction and action of points. Both we are going to use in a electrostatic machine, that is a Van de Graaff generator. Electrostatic induction and action of points or corona distance. What is meant by action of points? The leakage of charges at the sharp ends of a conductor, we call it as action of points or corona distance. These principle we are going to use it in the working of a Van de Graaff generator. So this Van de Graaff generator is specially designed to store the charges. It was designed by Robert Van de Graaff in the year 1929. It consists of a hollow metallic sphere. The hollow metallic sphere. This hollow metallic sphere is mounted on an insulating stand. So this is a insulating stand. The hollow, this will be the center of this hollow metallic sphere. Let A be the hollow metallic sphere. Here I have two pulleys. Let B, C be the two pulleys over which a silk belt runs over. So over these two pulleys, a silk belt, a belt which is made up of silk cloth runs over these two pulleys, and this pulley, that is the bottom, that pulley C is run by an electric motor. It is run by an electric motor. Here I have two comb shaped conductors. It is connected to a battery of potential 10 power 4 volts. How much potential we are going to supply for this comb? E, this is G, and here I have one more comb shaped conductor. Let this be as E. What is here? D and are two comb shaped conductors. Here this conductor, these two conductors are near to this pulley B and C. E. So this comb shaped conductor, it is connected to the inner end of the sphere, hollow metallic sphere. It's a hollow metallic sphere. Let A be the hollow metallic sphere and B and C be the two pulleys over which a belt made up of silk runs over. The pulley C is run over by an electric motor. It is connected to electric motor. When the motor runs, this pulley also runs. Over here I have a silk belt which is running over these two smooth pulleys. Here I have two, say, comb shaped conductors D and E one at the bottom of the pulley and one which is connected to the inner side of the sphere. This is the construction of your Van de Graaff generator. What is the major use of this Van de Graaff generator? It is used for storing charges, and I can also produce a potential up to 10 power 7 volts. How much potential I can produce up to in this Van de Graaff generator? To a value of 10 power 7 volts. So to begin with, I am going to give a potential of about 10 power 4 volts to this conductor D, to this form shaped conductor D. Here, since it is a positive charge, what happens due to the action of point? Here we can draw this pulley separately. This B and this is C. Here I have 2, this is D, and one is here, this is B. Now, this is connected to a positive terminal of a battery which gives a potential of about 10 power 4. So, here what happens at this point? Due to the action of point, more number of charges will be stored at the point. This is very close to the silk belt. Now, the air surrounding this pointed end will get ionized and negative charges will be attracted towards the sharp end and the positive charges will be repelled away. So, first what will happen here? Due to the action of point at the comb D, since it is connected to the positive terminal of the battery, due to the action of point, what happens? More number of positive charges will be stored at the sharp end. Now, here the sharp ends, when it stores the charges, what happens? It starts leaking the charges due to the ionization of air. When the air gets ionized in its vicinity, this negative charges will be attracted towards the positive charge and positive charges will be repelled away. These positive charges stick to the silk belt, and since it is running like this, the positive charges will be carried by the belt till it reaches the comb E. When it reaches the comb E, here this is connected to the inner side of the sphere. Here the E is connected to the inner end of the sphere hollow metallic. When it reaches here, by the process of electrostatic induction, what happens to this at this end? We know what is meant by electrostatic induction. We are going to produce charges without any contact with each other. When it reaches, when a positive charge reaches here, the comb becomes negative charge by the process of induction, and the outer surface, that is the sphere, it will become positive charge. So, by the process of induction, electrostatic induction, this comb E gains the negative charge and the sphere gains the positive charge, and the positive charges will be uniformly distributed over the sphere. Then, when it gains the negative charge, it will be accumulated at sharp end. Again, when the air gets ionized at this place, near this region, when the air gets ionized, the positive charges will be attracted towards the negative charge and negative charges will be pulled away, that is thrown away due to the force of repulsion. These negative charges which are pulled away or thrown away will be ionized. So, they will neutralize the positive charges in the silk belt. So, first what is happening when the positive charge goes near here? By the process of electrostatic induction, the comb E gets the negative charge and the sphere gets the positive charge. Here at the sharp ends of the conductor, all the negative charges will be accumulated. Because of this, we know that the air gets ionized and the positive charges will be given, will be here near the pointed end, and the negative charges will be pulled away. So, these negative charges, they will neutralize the positive charge of the silk belt before it reaches the pulley. Before it reaches the upper pulley, that is B, this belt gets neutralized and the ascending belt will have no charge. So, this ascending belt will be having no charges. So, the ascending belt will be having only the positive charge. So, here we are using both the principle, one the induction and also the action of point. So, here we are using the action of point, because of that it gains the positive charge and the silk gains the positive charge, and when it reaches here, because of process of induction, the comb E gets the negative charge and the positive charge will be given to the sphere. And again, due to the process of ionization, due to the ionization of air, positive charge will be attracted towards the comb and negative charges will be repelled away. These repelled negative charges will go and neutralizes the positive charge on the silk belt. So, when the pulley descends like this, it will be not charged. So the descending pulley will have, the descending belt will have no charges at all. What happens when again it comes here? It will be having no charge at all. When it comes here again, due to the action of points, again it gets a positive charge. It goes, it is the form E. This positive charge on the silk belt will get neutralized by the ionization of the air, and when it descends here, it will be having no charge at all. So this process will be going on. In each process, in each cycle, more number of positive charges will be stored here. So these positive charges, one in each cycle, number of positive charges will be going on increasing. If the more number of charges are stored, the potential developed will also be more. So this process continues till it attains a maximum value or a limiting value. So the storage of positive charges on the outer surface of the sphere, it will be going on till it attains a maximum value or a limiting value. When it attains, what happens? It has attained the saturation level. It has attained the maximum value. So maximum number of charges only it can store. It has reached the maximum value. After that, what happens? If you are going on giving charges to the sphere, it starts leaking the charge. So only it can store the charges up to a limiting value only. After it has attained the maximum value of the limiting value, it can't store the more number of charges. It starts leaking the charges due to the ionization of the air. Why it is leaking the charges? After it has attained the maximum value, due to the leakage of charges due to ionization of air. So to prevent this, what we can do, the whole apparatus, we can place it in a evacuated steel chamber, or I can keep it in a gas filled steel chamber under very high pressure. So how I can protect this? By the leakage of charges due to ionization of air, the whole Van de Graaff generator, the whole setup, I can place it inside a gas filled steel chamber under very high pressure. If I keep this Van de Graaff generator in a gas filled steel chamber under very high pressure, I can stop the leakage of charges due to the ionization of air. The leakage of charges I can stop by keeping it in a gas filled steel chamber under high pressure. So this is the way I can produce up to this. So by this Van de Graaff generator, I can produce a potential of about 10 power 7 volts. So here I can accelerate neutrons, but I can't accelerate electrons in this Van de Graaff generator. This is the use of using the Van de Graaff generator. So what is the limitation of this Van de Graaff generator? It should be kept in a gas filled steel chamber to avoid the leakage of charges due to ionization. That is the limitation. The last one, where it is used to produce the charges, or it is used to store the charges, and it is also used to accelerate positive ions only. I can't accelerate negative ions using a Van de Graaff generator. It is used to accelerate positive ions like neutrons and protons. In the process of nuclear disintegration, we are going to use this Van de Graaff generator. So this is an important 10-mark question in this lesson. The full theory part, it's a very important one. Just to understand how is the construction, and the drawing is very important. Construction of the apparatus and the working of the apparatus. What happens here at the comb D and what happens here at the comb E. Here first action of points. Here we are using both the principle, that is electrostatic induction and action of points. Here what happens after it has reached the maximum value? It starts leaking due to the ionization of air. To stop this, to protect this, what we are going to do, the whole arrangement is kept in a gas filled steel chamber under very high pressure. This is the way I can protect the leakage of charges due to the ionization of air. And here I can accelerate the positive ions like protons and neutrons. So I can accelerate protons and neutrons here to, in the process of nuclear disintegration, we are going to use this Van de Graaff generator. Up to what potential I can develop? I can produce a potential of at a high value of 10 power 7 volts. This is the main use of your Van de Graaff generator. So important 10-mark question.